Hi everyone, today we are going to be drawing Lewis structures or electron dot structures, or sometimes known as electron dot diagrams. So just to review, remember we're going to focus on the main group elements, so that's these guys over here and these guys over here. Okay? And so these elements, we can easily predict the number of valence electrons that they have. So everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons, right? And then we skip over the transition metals. We don't really care about them too much. And then we have group 13 has 3 valence electrons, and then so on and so forth, with the noble gases having 8 valence electrons. Don't forget that helium is an exception. Even though it's in the last column, helium only has 2 valence electrons. Okay, so it goes 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Remember, 8 is the maximum number of valence electrons that you can have. So valence electrons, of course, are the outermost electrons found in an atom. Okay. So what do you think these dots on these elements represent? If you said valence electrons, you are correct. So today we're going to learn how to draw these Lewis dot structures or electron dot diagrams. Okay, let's take a look at a few examples. So we got magnesium. So magnesium, I don't have my periodic table, but magnesium has 2 valence electrons. So how do we draw these 2 valence electrons? We're just going to draw a dot here and a dot here. Okay, or you could even do it on 2 opposite sides, right? Or you can even do it like this. What about chlorine? So chlorine is in group 17. It's got 7 valence. How would we draw chlorine? So chlorine, we're going to draw a dot on each side first before we double up. So 1, 2, 3, 4, 5, 6, 7. Okay, so it doesn't matter where that lonely dot is, as long as you make sure you draw 1 dot on each side first before doubling up. Okay. Same for phosphorus. So phosphorus has 5 valence electrons. Again, it's in group 15, so it's got 5 valence electrons. So we draw 1 dot, 2, 3, and then 4, and then that 5th one can go anywhere else. Okay, what is incorrect is if you pair them up before each side has one. So notice this is empty. This would be incorrect. Okay, so make sure you have a dot on each of the 4 sides first before you pair them up. And I'm just writing the symbol of the atom in the middle here. And that's how you draw Lewis dot structures. Already halfway through our lesson. Okay, so how can atoms become happy or stable? How many valence electrons do they want? So remember the octet rule, a little review here, states that atoms want 0 or 8 valence electrons, right? They want an empty or full valence shell. So here we're going to draw the ions, okay? And so let's start by drawing the atom first. So sodium has 1 valence electron. It's in group 1. Now, if it wants to become an ion, right, you ask yourself, is it going to gain or lose electrons to get 8? So for sodium, it's a lot easier to just get rid of this electron. So that's exactly what it's going to do. It's going to lose all of its electrons and have no valence electrons. When it does that, it's going to form a +1 charge. And so to indicate an ion, we want to make sure we include brackets and the charge. So make sure you include that. Brackets and the charge, okay? So that's a positive ion. When we get positive ions, notice there are no valence electrons, no dots around the sodium. What about oxygen? So oxygen's got 6 valence electrons. 1, 2, 3, 4, 5, let's do 6 here. So for oxygen, would it be easier to gain or lose electrons to get 8? Since it already has 6, oxygen is going to gain 2 more electrons, right? Because it wants that full octet. So it's a lot easier for oxygen to gain 2 electrons than it is to lose 6. So when it gains 2 electrons, it's going to form a -2 charge, okay? Because it gained 2 electrons. So for sodium, we saw that it lost 1 electron, which resulted in a positive charge. For oxygen, it gained 2 electrons, which resulted in a negative charge. Make sure you include the brackets whenever you draw these ions in your structures. And you're always going to have either 0 or 8 valence electrons. All right, a few more examples here for you to try yourself. I will do 2 of them. I'll do magnesium and sulfur. So magnesium, again, find it on the periodic table. You'll see that it's in group 2, so it's got 2 valence electrons. 1, 2. That's the atom first, so we did that. Is it want to gain or lose electrons to get to 8? Well, since magnesium only has 2, it's going to be a lot easier for it to just simply lose those electrons if it just gives those away. So if it loses 2 electrons, we're left with none and a +2 charge. Okay, so when you lose electrons, you form positive charge. If you gain electrons, you'll form a negative charge. Let's look at sulfur. So sulfur is in the same column as oxygen, group 16, which tells me it has 6 valence electrons. So 1, 2, 3, 4, 5, 6. And so for sulfur, it's going to be easier to gain 2 more electrons. So it's going to have 1, 2, 3, 4, 5, 6, 7, 8. Again, when it does that, if it gains 2 electrons, it's going to become an ion with a negative charge. Okay? So again, just to recap, when you lose electrons, you form a positive charge equal to however many electrons you lost. If you gain electrons, you're going to form a negative charge equal to however many electrons that you gained. All right, so make sure you try the chlorine one on your own. And here are the answer keys if you want to look at chlorine here. Practice doing these, and don't forget your brackets and your charge if you're doing ions. If you're doing regular atoms, then you don't need the brackets. All right, practice these and make sure you ask me any questions if you